Hello all. Today, in the course of mechanical engineering, we are studying elements of mechanical engineering. And today's topic is CNC Systems, Computer Numerical Control Systems. My name is Ramacharyulu. I am working as an assistant professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, College. Now, as a part of fifth module, we are studying the course name is Elements of Mechanical Engineering, where we are going to study the CNC systems. So the whole thing is divided into two parts. This is part 1. CNC stands for Computer Numerical Control Systems. So before going into the actual topic, we should know what is a Computer Numerical Control System. Before that, NC control systems. Now, we have to see what is numerical control. Suppose I have a machine which can be used for any mechanical operations or manufacturing operations. Now, if I want to create an object, I have to use this machine and I have to do some operations. For that, I need skill. Like the skill can be obtained by a lot of experience. So, sometimes even the skilled person cannot do a precise job. He cannot give a 100% accurate result while machining the object. That is why. And another thing is, the human being will take more time. Okay. So these two things, precision and less time, these two things should be overcome with the help of the recent advances in the manufacturing technology. So the one important advance in the manufacturing technology is numerical control. So we have connected a numerical control machine to the manufacturing system. Manufacturing system, one example is lathe machine. So I have connected a numerical control system to the lathe machine so that this machine can work on its own precisely and it takes less time compared to a human being. So let us see how this numerical control was first invented and what is the basic properties of any numerical control. So first thing is, back in the year 1940, where the Second World War is in wake, the USAF, which stands for US Army, US Air Force, United States Air Force. So they wanted to make lot of new aeroplanes for the purpose of war. That is when they have very less time. They may have very skilled persons, but they don't have machines which can work in less times, because human beings can do the same work, but they will take more time. That is when they started thinking of an automated system. Automated system means which can operate on its own. So they have invented this numerical control system, which is to be attached to the manufacturing system so that it can develop or it can produce a lot of mechanical elements. So US Air Force, in the year 1940, they started developing this numerical control. And these numerical control machines are very rampantly used in production of the aircraft systems for, the Second World War. The Second World War lasts for like 5 to 6 years. So that is when very less time is there. They have to produce lot of aeroplanes, because every day when the aeroplanes go for war, there is no guarantee that the aeroplanes will come back safely, because they will be wrecked out. Okay. So that is when they have invented this numerical control. So to speed up the production of the aeroplanes or fighter jets. And then first commercial numerical control machine was developed in 1952. So after the World War is over, this technology, numerical controlling technology, has been used for, commercially used for manufacturing processes in the year 1952. A lot of developments and lot of technology developed was only during the war. pause because of emergency. And then we'll see. This is a form of programmable automation in which the mechanical actions of a machine tool or other equipments are controlled by a program containing a coded alphanumeric data. So what is a numerical control system? Numerical control is nothing but it is a programmable automation or set of operations which are coded in the form of alphanumeric data. We'll use numbers and words to code the program. So this code can be called as a numerical control system. So the numerical control system will have we have seen in the last class, it will have a control system which will run a program that operates the machine which is working with the control system. Okay. So when we want to operate a machine or when we want to operate a machine tool, then we should need some coded program in order to make the machine move from one place to another place or make the machine work, or when the machine has to start and when the machine has to stop. All these things has been coded in the alphanumeric data which is given as a program. And then the alphanumerical data represents relative positions between work head and work part. Now, before understanding this point, we should know what is work head and work part. Simple. Any machine will have two parts. First one is workpiece. Here they are calling this as work part. And then second one is work head. Work head is nothing but tool. So these two things are very key when we are trying to manufacture a machine part or any element. So work head is nothing but the tool post which is attached to the machine where the tool will be fixed and it can be given feed. And then work part is nothing but the workpiece. Okay. These two are the important things we should know. Now let us see this point. The alphanumerical data represents the relative position between work head and work part. What is the relative position? That means, suppose I take the example of a lathe machine. In lathe machine, we will have a chuck which is being rotating at certain RPM. To this chuck, we will fix a workpiece, and on the tool post, we will fix a tool which is to be moved front and back or left and right. This tool post can move in four directions, in all directions. Okay. Now this tool can be given some feed so that it can cut the material from the workpiece. Okay. Now the relative position between the workpiece and the tool should be given in the form of a program. So that is what we are talking about. This program can be given to the numerical control system so that it can remove the material from the object. And then work head is the cutting tool and the work part is the object being processed. That is what we discussed just now. And let us go to the next slide. So the program of instructions can be changed to process a new job when the current job is completed. This is one best feature of numerical control system, that the program of instructions can be modified at any time so that we can change or modify the design while we are working on the machine. Okay. This capability to change the program makes NC more suitable for low and medium production rates. Okay. So that is what written here. So the capability of changing the machine program, the capability of changing the program makes the NC programming is very suitable for low and medium production rates. So while we are manufacturing a tool or we are manufacturing a workpiece, so this NC, we can go to this NC board panel and we can change some codes, and so that the output program can be modified in such a way to get the required shape and size of the object. Okay. And then we'll see some of the applications of NC, applications of numerical control system. So the first application is machine tool applications such as drilling, milling, turning and other metalworking operations. Okay. So We can do operations like drilling, milling, turning, and some other metalworking operations. So these machines are already there, where we can call them as conventional machines. These machines should be operated by a skilled human being for getting the required output. So drilling is making a hole into the workpiece. Milling means removing the material so that it can be developed into a new part. Turning means removing the material, like we can decrease the diameter or decrease the length of the object by using turning operation. And some other metalworking operations are there. All these operations are conventional. They can be done by a human being with the hand. But these machines are now operated by numerical control system, which is given a program to do the operation. And then non-machine tool applications such as assembly, drafting, and inspection. So along with the drilling operations, drilling, milling, turning operations, we can do some other non-tool applications where we don't have any tool. We don't use any tool here. We can do some other operations like assembly, drafting, and inspection. Assembly means we can assemble two parts, like we can assemble the two parts in a car body, and we can drafting of the body can be done, and inspection. After the complete assembly of the body, we can inspect whether the objects has been perfectly assembled or not, and we can check the quality of the parts also. So these are some of the basic applications of NC. Now we have seen, as a part of CNC machines, computer numerical control systems, we have seen what is numerical control. So this is only a part. But if we want to see what is a computer numerical control, this numerical control is carried out by a computer. We can see the difference here. This is a conventional type of machine. In the first image we can see this is being operated by a numerical control system. So this, whatever the object here I have shown in the circle, so this is the numerical control system. This will have a panel, it will have some buttons or switches, where it will have a small screen where we can upload or download the program, and we can change the program of instructions within the numerical control system itself. We don't need to go anywhere. We can change the instructions here itself. So this machine, this numerical control machine, is connected to the operating manufacturing machine, and it can be controlling the entire thing. Now whatever the program is there, that can be given into this machine, numerical control system, and this will operate the entire machine without the intervention of any human being while the process has been started. Before the process, we have to give the codes and program, and then once it started working, it will do the process, and it will complete. By then we can take the workpiece easily. Okay, so this is numerical control machine. Now CNC machine. What is CNC machine? This numerical control machine is somewhat old. We have replaced the numerical control system with computer numerical control because of the lot of advancements in the technology has happened. The computers are used everywhere, so that is why the numerical control system is replaced with CNC, computerized numerical control. See, in this image we can see this is a machine, or this is a 3D printer. Okay, this machine, this might be a milling machine. So this machine is being operated with the help of a computer. So the numerical control system is slightly modified and it is connected to a computer. Now we can give programming or codes directly into the system itself, computer. So with the help of this CNC machine, what is the advantage of this CNC machine is, we can change the program here itself. What happens in the numerical control system is, we have to go to a computer where we have to write the code, then we can bring the code and we have to give it into the system in numerical control. But in computer numerical control, CNC machines, whatever the code that is there, that can be changed or modified dynamically. When the system is working, dynamically we can change the codes, and we can change the code here itself in the computer. No need to go anywhere. So that is why The CNC machines are more fast and more accurate than NC machines. Both are same, but accuracy and speed are more. Now we'll go to the next slide. We'll see what is a computer numerical control. So CNC stands for computer numerical control. The computer numerical controls has been developed in 1952 after the World War has completed. People already used the numerical control system, so that they have started using the computers for controlling the machines numerically. Due to the advancement in the computer technology, the cost of computers has been decreased. So here we can say, back in the year 1950s, mostly only big companies with large investments are using computers. No other companies have the access to computers because they are very costly, yet they are very slow. They have very small RAM of like 12 MB. Back in the year 1970s, where NASA used a computer for landing the spaceship on the moon. Do you know what is the RAM memory of that spaceship computer? It is about 12 MB. 12 MB is the RAM, or it is the maximum storage capacity of that spacecraft computer, which is used back in the year 1970s. So that is why the computers are very slow than in 1950s. But when the time passing on, the computer technology has so advanced that the speed and cost are rampantly changed. You can see the speed of the computer is increasing day by day. Even now, we can see the speed is increasing. Speed of the computers are increasing. And as many manufacturing companies are coming forward to manufacture computers, the cost of the computers are decreasing day by day. So this is one major advantage of introducing the computers into numerical control machines. So that is what written here. Due to the advancement in the computer technology, the cost of computers has been decreased and the speed of the computers has increased. That is why, compared to numerical control machines, maybe numerical control machines have survived about 10 years. The CNC machines, with the advancement in the computer technology, the CNC machines have been developing since then, back 1950s. Now, in the year 2023, nowadays, still the computers are being developed to improve the efficiency of the CNC machines. Okay, so the numerical control is incorporated with the computer technology to develop computer numerical control. So this is what a CNC stands for. Okay, so here computer is attached to the numerical control system, where we can change the working of the numerical control system entirely. Now we'll go to the next slide. So let us see some of the features of CNC. We have studied what is a computer numerical control system, where we can give a program and make the machine work. So along with this general processing, we have some another features of any CNC machine. We'll see what are the first one is storage of more than one part program. This is the first advantage when compared to NC machine. Because we are using a computer here, we can store more than one numerical code. Back in the numerical control machines, we can store only one program. If we want to do another job or we have to change the design, we have to delete this program from the numerical control and we have to upload another program into the system. So only one program at a time can be possible in numerical control systems, whereas in CNC machines, more than one part program can be stored because we have a lot of memory available in the computer, so that each time new program can be used. Second one is various forms of program input. Different types of program inputs can be given because we are using computers. We can give, like in NC machines, we have to give codes. We have to give codes. If we want to make the tool to move from one place to another place, we have to give codes for each particular movement itself. Now, what in CNC is, we can actually give the drawing itself. If I want to manufacture any part, I can simply give the drawing of the object into the CNC machine or computer. So what it will do, it will convert the drawing into the required code, and this code will be utilized in the machine. Back in the numerical control systems, we have to give codes. Now in CNC, no need for codes. We can simply give the drawing from any software, any drafting software like AutoCAD, CATIA, any kind of software we can use for drawing the object with the required dimensions. This object can be feed into the CNC machine so that it will convert the code, it will convert the drawing into code, and that can be used for working of the machine. And then third point is program editing at the machine too. So because of the advancement in the technology and the programming, the program can be edited dynamically at the machine itself. When the machine is working, we can change the code or we can modify the code so that we can get the required output. Okay. And then next point is fixed cycles and program subroutines. So this is basically any advantage of any NC or CNC machine. Fixed cycles can be followed, and then repeated cycles can be followed. Repeated cycle of operations. Like if I have a machine who is this machine is being operated by a skilled labor. So this machine can produce about 5 objects per 1 hour, because the labor or the workman who is working on the machine is very skilled. So he can produce 5 objects per 1 hour. Now, if I want to produce more objects, generally any person or human being can work for 8 hours. Like 8 into 5, I can produce 40 objects in a single shift. Maybe in 24 hours, I have 3 shifts of 8 hours. 40 into 3, I can produce 120 objects in a single day. In a span of 24 hours, I can produce 120 objects when a human being is worked on the machine. Now, as we know, the industrial revolution is happening all around the world back from the 1900s. So, industrial revolution stands for increasing the production rate because of the large requirement. So, I have to produce more objects with the given time, within the given time. Within the 24 hours, I have to produce more objects. I cannot purchase more machines. I will have some 10 machines which can produce 120 objects. Now, these 120 objects, if I want to increase means, even though in this 120 objects which are manufactured by some n number of labor, still some of them will be not accurate up to the mark, not precise with the given dimensions. So some 10 objects are lost because they are not perfectly turned. Okay, so I will get around 110 objects finally out of the quality check. Now, because this huge gap or huge difference in the accuracy or production rate, so number of objects can be repeatedly produced with the help of the CNC machines, where we can apply fixed cycles. Fixed cycles means we can make the machine continuously work for like 24 hours, but still we can produce more objects when compared to a skilled human being working at the machine. So fixed cycles we can fix, and programming subroutines also we can change. The programming subroutines can be changed so that each and every time we can use the same machine for different designs. Okay, because of the very advancement in the technology, we can use the same CNC machine for doing different operations. Simply we can change the code and we can change the subroutines. Okay, now here see this point, macros can be written. So whenever we are trying to do an operation, we have to write the code from starting line 1 to line 100. Suppose there are 100 lines of code in a program. Suppose if I want to use the same code, or if I want to use the same design made by other designer, and I will change some small corrections or some modifications to that code, and I can use the same code. Okay. Now what is macro is, I can use this code. This is a macro. I can use this code, and this is predefined in the system. This is already there, already saved in the system. I can open this program and I can change some things, or I can modify some things, and I can use this program within very less time. I don't have to write 100 lines of code here. I can simply open this program and make the necessary changes, and I can use this program very simply. So that is why macros can be written in CNC. Macros are nothing but predefined programs which can be used by human beings. Which can be used by the user, so that they can be modified accordingly, and they can be used for required number of times. Many times you can use them. And then last one is, acceleration and deceleration calculations can be done. So acceleration and deceleration calculations means, when the machine is working, the machine will be rotating at some RPM, like 300 RPM, like that. So sometimes we want to increase or decrease the speed, and these increasing or decreasing the speeds also plays a major role while we are designing an object. While we have to calculate the time, what time is taken for each object is being produced. Suppose if I have an CNC machine, I want to produce a tool, I want to produce any object. So the time required for this object should be calculated based on the tool loading time, tool unloading time, tool processing time, and machine acceleration and decelerations also. All these calculations can be given by a CNC machine. CNC machine will give you these data automatically. Okay. So let us see what are the different things a machine will do when an object is to be manufactured. First of all, we have to give the program. We have to give the program to the CNC machine. Then this program is processed, and after that, tool loading has to be done. Tool loading, and then workpiece loading, and then after workpiece loading, we have to do the process, and after that, tool unloading. So these are the steps followed by any CNC machine. First of all, we have to give the program, and after that, tool is loaded into the machine, and then workpiece is loaded into the machine. Then the machine is started on. The machine has to accelerate from its zero position, like 0 speed to maximum speed. Then it will start cutting the workpiece, and then after processing has completed, it will be unloaded. So when we are producing only one object, there is no need for calculating the acceleration and decelerations of the machine. But when we are producing like thousands of objects in a day, we have to calculate this acceleration time also. This also should be taken into consideration while designing the production system. Okay. Now, these are some of the features of CNC. We'll go to the next slide. Some other continuations, some features are there. Communication interface. These are some other features of CNC. Communication interface, like we can download the part program, collecting operational data, interfacing with peripheral equipment. So we'll see the first one, downloading the part program. Suppose if I have a design and I have converted the code into the part program. Okay. Now, whatever the code we have written for working a particular object is called part program. So this part program, once given to the computer, this can be downloaded and it can be used in many times. As we have seen in the previous slide, that the part program can be written as a macro, and this macro can be modified accordingly and can be used in multiple times. Similarly, this part program can be downloaded into a external hard disk, and this can be used anywhere in any CNC system. And then second one is collecting operational data. Here we can collect operational data where we have to operational data like when the machine is working, we can collect some data like what is the speed of the machine, what is the speed initially before the process has started, what is the speed during the process, and what is the speed while the machine is removing the material from the workpiece. So these operational data, speed, uh, feed, etc. These are the operational data. These can be collected automatically by the CNC system. You don't have to put a separate machine or separate device which will measure this data. Okay, the CNC machine itself, it can do this automatically. And the third one is interfacing with peripheral equipment. Like interfacing with peripheral equipment simply indicates, suppose I have a CNC machine, I have a code, it will run the code and it will produce an object. Now this object should be given to another machine with the help of a robot. Here I have another CNC system. So this is CNC system 1 and this is CNC system 2. This is 1, this is 2. In between I have a robot. What generally robots do is, it can simply pick the object from CNC machine 1 and it can place the object in CNC machine 2. For this, what should I need? Now, interfacing with the peripheral equipment simply indicates that this CNC machine 1 should indicate to the robot that the manufacturing process or the process has been completed. Now you can take this object or workpiece from CNC machine 1. You can take it to anywhere. Okay, that is what CNC machine 1 will indicate to the robot. So this connection, so the indication between CNC 1 and robot is what we call it as peripheral equipment connection. Okay, so the robot is a peripheral equipment when compared to CNC. Now the CNC will tell the robot to take the object away. Now what this robot will do is, it will take that signal and it will operate accordingly. It will remove the workpiece from the object from the CNC machine 1 and it will take the CNC machine, it will take the object to the second machine, where this robot has to send a signal to the CNC machine 2 that it has placed the workpiece in position. Now the CNC machine 2 can start operating on its own. Okay, so both ways, the CNC machines and robots should be interrelated and they should be connected in such a manner so that they can be working in union. Union means they can be collectively working for producing an object. Now, another important feature of CNC is diagnostics. Like whenever the machine is operating at abnormal speed, or it is some parts of the machine are malfunctioning, or any damage has happened to the machine, or any problem has happened with the motor which is running the manufacturing machine. So those diagnostics can be automatically collected and they can be shown in the CNC machine. Okay, no need to check within the machine, because these nowadays these CNC machines are very complex. Now the CNC machine itself can diagnose any malfunctions or damages within the system. Okay, here malfunctions and failure analysis. So simply both the same. Malfunctioning and failures of the machines can be easily identified, and one important feature is they will continuously monitor the maintenance. They will continuously monitor the maintenance, and the CNC machine itself will tell you that maintenance is required for any particular part of the CNC system. So not only the diagnosis, not only the alert that your machine has failed, these CNC machines will tell you that maintenance should be done to the particular part of the CNC system. Okay, and then tool life monitoring also, because we are continuously working uh, for like 24 hours a day, the tool will be worn out easily. So the tool life or the tool sharpness, etc., all these things can be, these reports can be taken out and they can be shown in the CNC system. So CNC systems are very advanced. We are replacing the human being with the help of a computer. So the computers they can, with the help of sensors, they will collect all this information and they will show to the end user who is using the CNC machine. So preventive maintenance notices can also be given by the CNC machine. So these are the features of CNC machine. And in the next slide, we can see configuration of CNC machine control unit. Configuration of CNC machine. So this is the basic block diagram of any CNC system, and we can see different parts of it. So here we can see the central line is there. This is system bus cable, where the entire system is connected to this cable. Okay, system bus. So each and every part of the system will be taking or giving the information to this system bus. System bus is again connected to the whatever the machine is there, the manufacturing machine. It is connected to the manufacturing machine. Now see, the first part is memory. So the memory of the CNC machine controls, it will have important parts like ROM and RAM. We already know what is ROM and RAM. So ROM is nothing but read-only memory, and RAM is random access memory, where the memory will have these two parts. The ROM will contain all the operating system required for running the entire computer, and RAM will contain the part programs. Part programs means whatever the program we have given to the CNC systems in order to manufacture them. So those are called part programs. This program is stored in the random access memory, where we have to use these two for saving the program or operating system. Now this is the first part, memory, and the second one is central processing unit. So the central processing unit will access the information from the memory, and it will also access the information from input or output devices, and then this entire information is processed in the central processing unit and it is sent to the control sequence. Okay, so we know this is simply, we are using these words when we are explaining a computer. So CPU is the brain of the computer. It will take the information from input or output devices. So input device is nothing but operator panel. Whatever the panel is there attached to the CNC system, that is an input panel. We can give instructions into it. And a tape reader. Back in the days, we used to have tapes where we have stored the program code into the tape. Okay. Now this tape can be inserted into the machine. So these tapes are used back in the year 1950s or 60s, where the floppy disks are not being invented. After that, after tapes, we have used floppy disks, and after that we are using hard drives. Okay. Now tape reader is also an important input device which is used in the CNC system. The design is given into the tape, and this tape has to be inserted into the CNC machine so that it will read the information from the tape, and this is given as the program. This program can be processed in the CPU, and this CPU will give the instructions to the machine. Now these three are related. Top three parts are memory, CPU, and input or output. These are general topics. And bottom we can see machine controls, machine tool controls. So what is a machine tool control? All the above systems will combinedly work and give one signal to the machine tool control system. Now this control system, what it can do is, it can manage the position and orientation of the tool. It can manage it can modify the position of the tool. So we can change the position of the tool, we can give feed, and we can change the spindle speed. So whatever the machine, whatever the workpiece is fixed into the chuck can be The chuck speed can be modified or controlled by using this machine control. Okay, this system is the controlling part where the tool speed, the tool feed or the spindle speed can be controlled. And see the last one, sequence control. So the sequence control will controls the flow of the coolant, fixture clamping, that means how tightly we have to fix the object into the chuck, and then tool changer. While some CNC machines will have a single tool post where we can attach a single tool, most of the CNC machines will have multiple tools. Multiple tool holding devices will be there. So we can do different operations on the same workpiece in the same machine only. Simply we have to fix different tools in the tool post. They will be used one by another. So bottom, these two, machine tool control and sequence control, these two are the key controls of the these two are the parts of numerical control generally. And the top part is computer simply. So computer, top computer, bottom numerical control. So totally we can call it as CNC. So this entire system will give signals to the machine. So in machine tool control, we can control the position and speed. In sequence control, we can control the how much amount of coolant has to be flown onto the workpiece. Okay, while working, because the workpieces will get heat when working. So we have to give a coolant and then fix a clamping. How tightly we have to clamp the object, or whenever the completion of the operation, we have to remove the workpiece from the tool holding device, and then tool changer also. We can change the position of the tool. If we have a multiple tool device where the tool post will have more than one tool, the tool post can be rotated in such a manner that we can change the tool. We can rotate the tool post and we can use another tool for operation. Now, so this is the basic configuration of a CNC machine control unit. Okay, it contains 5 parts, and these two are the numerical control, and the top part is the computer. Totally we can call it as CNC machine. And going to the next slide, what are the different softwares required for CNC? So we are not going to detail about how many companies are producing CNC softwares. We are seeing what are the basic components of any CNC software. What are the components required for a CNC machine has to work properly. So the first thing is operating system software. Firstly, we have operating system. So any computer will have an operating system like Windows, Linux or DOS. Okay, these operating systems should be there in order to make the numerical control work in the computer. So this is the basic operating system. And then second one is machine interface software. Machine interface software is nothing but it will convert the programming code whichever we have given in the operating system. This program can be converted into code recognized by the machine, numerical control machine. So this is machine interface software. And then third one is application software. So application software is nothing but we will have an application software where in which we can make the modifications, where we can design a part programming, where we can write the code. Actual code will be written in the application software. Okay, application software is the key thing where operating system is generally it is there in any computer. Machine interface is also important for converting this programming code into movements. These movements can be done by the machine interface software. It will convert the code into required machine level code. Okay, so these are the 3 important components of any CNC software: operating system, machine interface and application software. So far we have seen, in today's class we have seen what is in numerical control. We have seen what are the computer numerical control, and then we have seen features of a numerical control. features of CNC. And then after, we have seen what are the block diagram of the control unit, block diagram of the central unit, control unit. And then we have seen what are the CNC softwares. So this is what covered so far in this lecture. So in the next class, we'll see some other applications, advantages and disadvantages of CNC machines. And we'll meet in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.